Every day, without a second thought, we flip a switch and expect instant light to flood the room. It's a simple act, a modern convenience we often take for granted. But behind that effortless flick lies a fascinating story of innovation and energy transformation. But have you ever paused to truly wonder what's really happening inside that seemingly simple bulb? What unseen processes are at play to conjure light from the darkness? For decades, the standard light bulbs in our homes were basically tiny heaters, inefficiently converting electricity into both light and a significant amount of heat. These incandescent bulbs were notorious for wasting most of their energy, emitting more heat than light, a clear sign of inefficiency. Now, LEDs, light-emitting diodes, have completely changed the landscape of lighting technology, offering a far more efficient and versatile solution. They're in your phone, providing the bright, clear display you rely on every day. They're in your TV, illuminating your favorite shows and movies with vibrant colors. They're in your car, guiding your way with bright, energy-efficient headlights. And the best part? They use just a fraction of the energy compared to their outdated predecessors, making them incredibly cost-effective. Imagine the difference between starting a bonfire, a massive, energy-intensive undertaking, just to toast a single piece of bread. That's analogous to using an incandescent bulb versus using a toaster, a targeted and efficient appliance. That's the monumental leap we've made, transitioning from inefficient old bulbs to the brilliance of LEDs. LEDs are remarkably efficient, converting a much higher percentage of electricity into light. They're incredibly long-lasting, saving you money and reducing the need for frequent replacements. And perhaps most importantly, they're significantly better for the planet, reducing our overall energy consumption and carbon footprint. But how did we get here, to this point of widespread LED adoption? What were the key breakthroughs that paved the way for this lighting revolution? Let's dive into the fascinating science and compelling story behind the LED revolution, exploring the innovations that have transformed the way we light our world. We'll take a look at how they're meticulously made, from the initial design to the final assembly. We'll uncover the secrets behind why they're so incredibly efficient, examining the physics that make LEDs such a game-changer. And we'll explore what makes them the undisputed champions of modern lighting, illuminating everything from our homes to our cities. Get ready, things are about to get bright as we delve into the world of LEDs. So, what exactly is an LED? You've probably heard the term thrown around, especially when talking about energy-efficient lighting. But what's the science behind these little marvels of engineering? What makes them so different from the light bulbs of yesteryear? It stands for light-emitting diode. Let's break that down. Light-emitting tells us it produces light, but the real key is diode. A diode is like a one-way street for electricity. It's a fundamental component in electronics, acting as a gatekeeper for electrical current. Current flows in one direction only. Think of it as a valve, allowing electricity to pass through in a single predetermined path. This is crucial to how LEDs function. LEDs are made from semiconductors, special materials that bridge the gap between conductors and insulators. These are materials that can be tweaked to control electricity. By carefully manipulating their properties, we can dictate how electricity flows through them. This is where the magic truly begins. Inside, there are two layers of these semiconductor materials, carefully joined together. One layer is doped with impurities to create an abundance of extra electrons, giving it a negative charge. The other is doped to create holes, which are essentially spaces where electrons are missing, giving it a positive charge. When you flip the switch and apply voltage, electrons jump across this junction between the two layers, filling those holes and releasing energy as light. This process happens at an atomic level, with electrons transitioning to lower energy states. This released energy manifests as tiny particles called photons, the fundamental units of light. Billions of these jumps, happening every single second, create the steady stream of light we see emanating from the LED. It's a constant cascade of energy conversion. Unlike old incandescent bulbs that waste a significant portion of their energy as heat, LEDs make light directly from electricity, converting a much higher percentage of the electrical energy into visible light. This direct conversion is a process called electroluminescence, a phenomenon where a material emits light in response to an electric current. It's a much more efficient way to shine, minimizing wasted energy and maximizing light output. Think of it as whispering a message directly to someone, ensuring the message is clear and concise, instead of shouting across a noisy room, where much of your energy is lost, and the message becomes garbled. That's why LEDs are so energy smart, converting electricity into light with minimal loss. No fragile filaments to burn out, no significant wasted heat dissipating into the environment. It's just pure, efficient light generated through a clever application of semiconductor physics. That's the magic of LEDs, a tiny component, a simple principle, and a world of bright possibilities. Building an LED starts with materials like silicon or gallium nitride, grown into flawless crystals in high-tech labs. These crystals are sliced into ultra-thin wafers, polished to perfection. Using a process called epitaxy, scientists layer different semiconductors just atoms thick onto the wafer. Each layer has a specific job, guiding electrons and holes to meet and create light. The wafer is tested, then diced into thousands of tiny chips, each smaller than a grain of salt. These chips are the engines of LED light. From raw crystal to microscopic marvel, the LED chip is a triumph of modern science. It's how we turn sand and chemistry into light. The raw LED chip is tiny and fragile, so it's packaged for real-world use. It's placed on a base, connected with ultra-thin wires and sealed in a protective dome. To make white light, a phosphor coating inside the dome transforms blue LED light into a warm glow. Multiple packaged LEDs are mounted on a circuit board with a heat sink to keep them cool. The whole assembly is placed inside a bulb-shaped diffuser, and driver electronics are added. Now you have a modern LED bulb, efficient, durable, and ready to light up your world. From chip to bulb, every step is engineered for performance. That's how LEDs go from lab to lamp. Let's dive into a head-to-head comparison. We're going to see how LEDs stack up against the old-school bulbs that have been lighting our homes for decades. It's time to put these lighting technologies to the test and see which one truly shines. Incandescent bulbs, while familiar, are incredibly inefficient. They waste about 90% of their energy as heat, meaning only a small fraction actually produces light. Imagine throwing money away with every flick of the switch. When it comes to energy efficiency, it's no contest. CFLs, or compact fluorescent lamps, represent a step up. They are better than incandescents, using less energy to produce the same amount of light. This translates to lower electricity bills and a smaller carbon footprint. However, CFLs aren't without their drawbacks. They contain toxic mercury, a hazardous substance that poses environmental and health risks if the bulb breaks. Plus, they often take time to warm up, leaving you in the dark for a few moments after you flip the switch. So, where do LEDs fit into all of this? LEDs, or light-emitting diodes. They use up to 85% less energy than incandescents, making them incredibly energy efficient. This significant reduction in energy consumption translates to substantial savings on your electricity bill over time. And they outlast both incandescent and CFL bulbs by years, offering exceptional longevity and reducing the need for frequent replacements. An LED can last 20 years or more, providing decades of reliable illumination with minimal maintenance. In contrast, incandescent bulbs burn out in just a few months, requiring frequent and costly replacements. LEDs are solid-state devices, making them incredibly durable and resistant to damage. They also operate at a cool temperature, making them safe to touch even after hours of use. Unlike traditional bulbs, there's no glass to shatter, eliminating the risk of cuts and injuries. Plus, they contain no toxic materials, making them environmentally friendly and safe for your home. They turn on instantly, providing immediate illumination without any delay or warm-up time. And unlike some other types of bulbs, LEDs aren't affected by frequent switching, so you can turn them on and off as needed without worrying about shortening their lifespan. In every category: efficiency, lifespan, safety, and convenience, LEDs win hands down. It's a total knockout. The advantages of LEDs are clear and undeniable. The old guard can't compete. Incandescent and CFL bulbs simply can't match the performance and benefits of LEDs. LEDs are the new standard for lighting, offering a superior combination of energy efficiency, longevity, safety, and performance. Why settle for less when you can have the best? Upgrade to LEDs and experience the difference for yourself. The future is bright, and it's LED. Embrace the future of lighting and enjoy the many benefits that LEDs have to offer. What makes LEDs so efficient? It's all about how they work. LEDs convert electricity directly into light. No wasted heat, no middleman. They shine light in a specific direction, so less is wasted. Old bulbs scatter light everywhere, needing reflectors and shades. LEDs stay cool thanks to heat sinks, which means they last longer and stay efficient. They can also produce any color directly without filters that waste energy. The result? Maximum light, minimum waste. That's why LEDs are the champions of energy savings. They're smart, targeted, and built to last. Efficiency by design. Making LEDs isn't easy. There are real challenges. Efficiency drops at high power, so engineers work to keep them bright and efficient. Achieving perfect color consistency is tough. Tiny differences in chips or phosphors can change the shade. Heat management is critical. Overheating shortens lifespan and shifts color. Manufacturing is complex and costly, requiring rare materials and precision equipment. But constant innovation is driving prices down and quality up. Overcoming these hurdles is what keeps the LED revolution moving forward. The science behind your light bulb is anything but simple. The LED story is just beginning. Smart LEDs let you control color and brightness from your phone, saving energy and adding convenience. Efficiency keeps climbing. Future bulbs will use even less power for more light. New materials are making LEDs more sustainable and human-centric, mimicking natural sunlight to boost mood and productivity. LEDs are powering innovations like Li-Fi for wireless data and micro-LEDs for ultra-bright screens. The future isn't just about better bulbs. It's about smarter, healthier, more connected lighting. LEDs are lighting the way to tomorrow. Get ready for what's next. Why switch to LEDs? 3 reasons. Save money, help the planet, and improve your life. LEDs cost a bit more upfront, but the energy savings pay you back fast. They last for years, so you buy fewer bulbs. Using less electricity means less pollution and a smaller carbon footprint. Every LED you install is a step toward fighting climate change. The light quality is fantastic. Choose the color and brightness you want. LEDs run cool, are safer, and make your home more comfortable. It's a simple upgrade with a big impact. By choosing LEDs, you're supporting innovation and a sustainable future. Change a bulb, change the world. Ready to buy LEDs? Here's how to pick the right one. Forget watts. Look for lumens to measure brightness. For a 60-watt equivalent, choose about 800 lumens. For 100 watt, about 1600 lumens. Check the color temperature in kelvins 2700 to 3000 K for warm, cozy light. 4000, 5000 K for cool, energizing light. Look for a high CRI, color rendering index, 90 or above, for true, vibrant colors. Match the bulb to your space and needs. With these tips, you'll get the perfect light every time. LEDs make it easy to create the atmosphere you want. Make the switch and brighten your world. You're ready for the LED revolution.